So, welcome to the second lecture on linear algebra. In the previous lecture, we have discussed about the introduction to linear algebra and benefits of linear algebra in machine learning. And today we will discuss about few examples in linear algebra in machine learning. So, the very first application or advantage in this case is dataset and data files. So, each machine learning project works on dataset and we fit the machine learning model using this dataset. Each dataset resembles a table-like structure which consists of certain rows and certain columns, where each row represents certain observations. Each row represents certain observations, and when we talk of a column, it represents certain features, or we can call these features as variables. The dataset is handled as a matrix, which is a key like data structure in relational algebra. Then in the dataset is divided into input and output for supervised learning model. It represents in the form of matrix X. That's why we say this is one of the linear algebra example in machine learning. The next example in machine learning is images and photographs. So when we talk of images and machine learning as a data example of linear algebra, so we know in machine learning images, photographs are used for computer vision applications. Each image is an example of matrix. So each image is example of a matrix. From linear algebra, because an image is a table-like structure consisting of height and width of each pixel. So this matrix will basically consist of height and width of each pixel. Moreover, the different operations on images like cropping, scaling, resizing are performed using notations and operations of linear algebra. Then, the next example is one hot encoding. So, in machine learning, we need to work with categorical data. Categorical data that represents, you can say, we having various categories like male, female, boys, girls, this way. So these categorical variables are encoded to make them simple and easier to work with, and popular encoding techniques to encode these variables is known as one hot encoding. In the one hot encoding technique, a table is created that shows a variable with one column for each category and one row for each example of dataset. So in this, how it is representing in the form of matrix. So here we are having one column which represents category, and each and every row is an example of dataset. So here each row is encoded as a binary vector which contains either 0 or 1 value. This is example of sparse matrix in case of linear algebra. And then the next example of linear algebra is linear regression. So linear regression is a popular technique of machine learning borrowed from statistics. It describes a relationship between input and output variables and is used in machine learning to predict numerical values. The most common way to solve linear regression problem using least square optimization, which is solved with the help of matrix factorization methods. Some commonly used matrix factorization methods are LU decomposition or single value decomposition, which requires linear algebra. And next example of linear algebra in machine learning is regularization. So in machine learning, we look for the simplest and possible models to achieve the best outcome for specific problem. Simpler models generalize well, ranging from specific example to unknown datasets. These simpler models are often considered models with smaller coefficient values. A technique used to minimize the size of coefficients of a model while it is being fit on the data is known as regularization. So common regularization method that are being used are L1 and L2 regularization. Both of these forms of regularization are a measure of magnitude or length of coefficient as a vector, and methods lifted directly from the linear algebra called various norm vectors. Then we also have another example, which is PCA, that is principal component analysis. Each dataset contains thousands of features, and fitting the model such as large dataset is one of the most challenging tasks of machine learning. A model built with irrelevant feature is less accurate than a model built with relevant features. There are several methods in machine learning that automatically reduce the number of columns of a dataset, and these methods are simply known as dimensionality reduction. The most common used dimensionality reduction methods is principal component analysis. So will have a separate video on PCA itself. Then the next thing that is there in this case is seventh example we can say is singular value decomposition. So this singular value decomposition is one of the popular dimensionality reduction technique and is written as SVD for short. It is a matrix factorization method of linear algebra, and it is widely used in different applications like feature selection, visualization, noise reduction, and many more. Then we have latent semantic analysis. So natural language processing is which we know is a subfield of machine learning, and it works with the text and spoken words. NLP represents a text document as large matrices with the occurrence of words. For example, a matrix column may contain known vocabulary words, and rows may contain sentences, paragraphs, and pages, with the cells in the matrix marked as the count or frequency of the number of times the word has occurred. It is a sparse matrix representation text. Documents processed in this way are much easier to compare than any other basis. After this, we have the next one as recommender system. So a recommender system is a subfield of machine learning, a predictive modeling problem that provides recommendations of products. For example, online recommendation books based customers' previous purchase history, online shopping is there. Fine. So next we have deep learning, which also uses this linear algebra. So artificial neural networks or ANN are the non-linear ML algorithms that work to the process brain and transfer information from one layer to another in a similar way. So these were few examples of linear algebra in machine learning. So if you have any doubt, then you can write your query in the comment box. Okay, so thanks for watching the video.